we finished talking about how safe locks work. And hope seeing that really gets you into appreciating the technology and creativity that goes into these locks. I really love them, and I hope you do too. Now we're going to talk about how manipulation works. And it's kind of a little bit magic about how the only thing you can really do is turn the dial left or right, and that you're going to be able to figure out what the combination is. And there are two things that you can do that we haven't really talked about. And one of them is determining something called the contact points. And that is basically here. So it is where the the nose is touching the edge of the drive cam. And on the other side as well, it bumps into it right here. So those are the two contact points. And we can find those, like, it's really obvious. If I just spin it, it stops right there. So these are they're very easy to find, but difficult to really accurately find. The second thing is on the dial here, we can really tell accurately what the reading is on the dial. You can see it's pretty much at pretty exactly here at 5. And we're going to be learning how to really get that down to super accurate. We're going to be trying to get down to a tenth of one of these. So between here at 5 and here at 4, we're going to need to be able to really tell about 1/10 of one of these. And I'll go through a really simple way of making that really easy. And the one that I use, because it's just so much easier to read, how I'll tell you. So by accurately determine where these contact points are, we'll be able to figure out what the combination is. And it's a little bit of magic, and that's what we're going to talk about today. We'll be talking about why that helps us determine what the combination is, and we'll talk about how to actually accurately place the cam on right on the edge of that nose, and to be able to do that consistently, and so that it's every time you do it, you'll get the same value. And also, we'll talk a little bit about how to read that dial very accurately. And I'm going to try and keep this video short and focused just on accurately reading those contact points and why we're doing that. And I'll be making some supplemental videos after this about how to do a scan through the wheel pack, which is the first step in doing manipulation, once we found out how to determine the contact points, and also about something called a high-low test, which once we found something that looks like one of the gates in the wheel, that we'll be able to tell which wheel that is actually on. And with that information, we'll just find the first number, find the second number, and then find the third number and open the lock. So join me and we'll go through this right now. The key point is that when there's a gate under the fence and the nose drops a tiny bit lower. And due to the shape of the cam gate, when the nose is lower, the contact points move a little bit. We can measure that tiny distance and find the gates. Here are two pictures of the lock with the wheels in different positions. On the left-hand side, you can see there's a gate underneath the fence. On the right, there isn't a gate underneath the fence. As I said, in this situation, on the left, the one at the gate, we'll have the fence lever and nose a little bit lower. As you can see, it's a really tiny difference. I'm also pointing out the shape of the cam gate. The difference in height between the two is very small, so I just want to point it out here. That horizontal red line shows the difference in height. On the right-hand side, you can see the little arrow that the nose is a little bit higher in that side and a little bit lower on the other side. The differences are very small. And bringing our attention to the very top of the lock, you can see 4 arrows. The 2 pointing down are showing the edge of the wheel pack. That's the big wheel there. And then there's a silver box, and that box is where the fence is welded to the lever. If you look at the bottom edge of that box, right where the arrows are pointing, You can see on the left-hand side, that box is just below the level of the wheel pack, and on the right-hand side, it's probably just a little bit above it. Let's look at the shape of this part of the cam gate. There's two sides, but this is the most important contact side. It's the one that's sloped, and what that slope does is it amplifies the motion of the nose coming down. So if we move the nose down a little bit, we'll see that this cam is going to turn, and that's going to change the reading on the dial. So if we just very slightly move this, you can see just very minute changes in that height. See that again? Just very minor changes in the height of the nose moves the cam. You can see it moves it quite a bit. Not a lot in all told, but small changes in that height move that contact point. So as this thing moves, that will be changing the reading on the dial. So let's go back to the other diagram and see that. Okay, back to our original diagram. On the left-hand side, we have the gate right underneath the fence, and on the right-hand side, that's not the case. So on the left-hand side, the nose is a little bit lower than on the right-hand side. And because it's a little bit lower, it's moved the cam or the contact point. So the cam is actually in a slightly different position. And we can see that on the dial, as I shown at the bottom. On the right-hand side, it's right at 12. And at the left-hand side, where the nose is a little lower and push the cam a little bit, it's at about 11 and a half, 11 and 3/4. And that's how we can measure the height of the wheel pack underneath the fence by looking at the contact points. Okay, so I did lie a little. In the perfect world, this technique wouldn't work. And the reason why it wouldn't work is, in essence, something called shadowing. And that just basically means that if you look at this, and there is a gate right here, that there's two other discs behind it, two other wheels behind it. And if the fence is on top of them, they won't actually allow the fence to drop lower than normal. Like if I'm here where there is no gates, we'll get the same height here as where there is a gate in the perfect world. And that's because all these discs would be exactly the same height at all places around. They'd be perfectly round. There'd be no little fluctuations. And that just doesn't happen in the manufacturing process. So in the perfect world, this wouldn't work. And I can tell just by feeling this with my fingers that these discs, these wheels aren't the same size. I can feel the manufacturing tolerances. This is a very inexpensive lock, so I think that's probably just due to the manufacturing isn't as high quality as some of the other locks, or I suspect that. But in general, they're all going to be slightly off. You know, different machines are making these. They're made when the machines were at different temperatures. You know, just two machines that are trying to do exactly the same thing with the same situation is going to be slightly different, and they'll be put together slightly different. The holes that are binding these will be slightly different. So, I do want to talk a little bit about gate shadowing or wheel shadowing, and that would be the situation here. We have a gate, and if one of the other wheels, let's just look at a two-wheel case. If one of the other wheels, I'm exaggerating this about as much as I can, but you can see the wheel behind it is now masking that gate. So if I'm scanning around here, it's the fence here is only ever touching that higher back gate. So there will not be a drop here. There won't be the fence height will not change as it goes along here. But in other situations, like in this case, this is also a really big exaggeration. You can see that the front wheel here is a lot higher here than the back wheel. So in this situation, as you're scanning around here, you'll see it'll come to that gate and suddenly you can hear it click. It drops down and then it'll come back up over here. So, and that's because the front disc here is higher than the back disc. And this doesn't have to be very much. Like the techniques that I'm showing you with the accurately reading the dial can probably show just a few thousandths of an inch change in the wheel. And that's the kind of distances we want. So the wheels will be slightly different shapes. They'll be slightly different sizes. They'll be put together differently. Even the tension in the locking mechanism here will affect the shape of the wheel as well. So they are not perfect. They're not perfectly round and not perfectly the same size. If they would, if they were perfectly round and perfectly the same size, the other wheels will not allow you to see the difference in height. They'll just mask it because in this case, the the fence is, let's look at this from the opposite direction. The fence will be running around this, and there isn't going to be any change in there. But due to tolerances, there will in general be. So the process is more difficult than I kind of explained, but as we go, when we talk about this in more detail and show you an example, you'll understand a lot better. But in general, you will, when you have these three wheels and you do a single scan of all these wheels, what we'll do in the process, we'll be looking at the fence height all the way around the wheel. And in general, some of these gates will be shadowed by a larger gate, a larger wheel, sorry. Some of the gates will be shadowed by a larger wheel, and you won't be able to see a dip when the fence is on top of it. Other wheels, you will see a dip. And the idea is that it's highly unlikely that all the gates will be shadowed, and then we'll be able to find the gate that isn't shadowed. And we'll talk a little bit about later about what to do if all the gates. It's possible that all the gates will be shadowed, and it's very hard to find one. And we'll just do slightly different mechanisms for finding them. We'll just basically rotate the wheels a little bit, and then can rescan with the wheels not quite in the same locations, and we should be able to pick it up. The other thing that happens is that the fence actually has a spring on it. Remember, this is the spring is pulling it down, but you can see there's a big distance that this is being pulled down. There's a big distance along the wheel pack. So what happens is it tends to be, and I'll exaggerate this, it tends to be, instead of perfectly flat like this, the wheel tends to be bent. The it bent. Sorry, the fence tends to be a bit bent. So instead of being flat like this, so instead of it being flat, it's actually at an angle like this. I'm totally exaggerating this, but it's at a bit of an angle. And that means the top wheel, which is wheel 3, tends to be found first, easiest to find. And that's because if you're looking if we're looking at the wheel 3 gate here, and this is at an angle, it's highly, you can, like, even I'll even shadow it. It's slightly shadowed now. The wheel 2 and 3 are slightly higher than it, so we wouldn't expect there to be an indication. But if we bend the gate a little bit, you can hear it. It will find it just because of that angle. And that is one of the reasons why, when you are manipulating, the most likely first gate that you'll find is from wheel 3, just because the spring is pulling it down. It's not perfectly flat, it's down at a bit of an angle. On the lock that's actually in the safe, usually I get a wheel 3 indication first. Sometimes I get a wheel 2 indication first. And I'm getting the wheel 3 just because it's not being really shadowed, and it's at a slight angle just because of the way the spring is pulling on it. So it's more likely, you can hear it, it's more likely to be found. And for when it finds the wheel 2, what's happening is that it just means that wheel 2 at that point is just a little bit higher than the other two wheels. So you're actually, if the you're actually, what's actually happening is it's like there's only one wheel because it's the highest wheel. the fence is only going to touch the first wheel, the first one wheel in general. In a perfect world, it'll be touching all three of them, but in general, because of different sizes, at any one time, it's probably just touching one of these. It may be just like a thousandth of an inch or 2 or 3 thousandths of an inch difference, but in general, it's only going to be touching one wheel. So as you move, you're doing a measurement, move it a little bit, do another measurement, move it a little bit, do another measurement. What you'll see is the wheel pack will be fairly consistent. And then when it hits the gate, it will come down, not this amount, it'll come down just a little bit. And what's happening is it'll come down and hit one of the other wheels. So let's look at what that looks like. So if we look at this, and I've got the first one a little bit higher, so when we're scanning, the fence is only touching that top wheel. When it comes down, it's just going to drop down a tiny bit. And then when it goes past the gate, it comes back up. And that's because the fence is just moving from being on top of wheel 3 and going to wheel 2 underneath it. And that happens in the gate because obviously if it's touching wheel 3 and wheel 3 is kind of no longer there, it's going to be resting on wheel 2. So that's the basic idea of what's happening. And as I said, the lower parts tend to be where the gates are, but they're not always the case. Lower parts are highly indicative, especially if you see the height go, you get pretty high, 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 and then it suddenly comes down, and then it suddenly comes back up. And these distances, like I said, are very small. They'll tend to be about a quarter of a number on the dial. So between, say, 6 and 6.5, or 6 and 6.25, or 6 and 6 1/8, those type of differences. So very small differences, but you can tell even a small change in height of these. That these happens when it's dropping from one wheel to another wheel because of that hole. And that's basically how the process works. I want to introduce my setup here on my particular safe. And I've made a minor modification to this. As you can see, there is a little piece of wire. All I did is took a piece of wire, twisted it out so it's straight, and taped it onto the dial. And then I went to the dollar store and got a little plastic container, and I cut a little piece of ruler and put it on here, and another one at a slightly different angle. And what's happening is this is one of my contact points right here, the more important one. You can see I have it so that I can read the exact measurement here. And we'll see that. I'll show that as we're actually using this, but I just want to show you how it works. And again, for the other contact point, it is indicating down here. So as these change, I'll just show you what kind of differences in change I can get on this. Let's do this at pretty much exactly 14. And we are indicating about 2.2, about 1.5 millimeters. I've moved this one dial location down to 14. It's now at about 2.5 on this scale down here. So I've now turned it so that one number change on the dial is now representing 10 millimeters of change on the ruler. And this ruler is totally easy to read. It's so it's very difficult to tell a tenth of a difference change in the numbers by looking at this dial. It's really easy to try it with this. So I recommend you do start with like taping a ruler on your safe. I don't recommend putting it down here. The reason why it's down here is just because I have two external cameras. I would actually put it up above the dial, and that's just because that's where your eyes are. It's much easier to see from that location. But all I did is tape a piece of wire on here, and then I just look at the two contact points and make sure that I can get a reading from them, and it makes the reading the dial super trivial. It's like super easy to tell a tenth of a number difference, like between 12 and 12.1. That's really easy to tell when it's set up like this. Just using your eye on this is quite difficult. I can't quite do it. I make the mistakes, and that's not something that I enjoy doing. So I would recommend starting off like this. And you just need like a little plastic container to lift it up so it's not like bashing into your hinges or whatever you have. Or if you have a practice lock, you can all I did is took a clipboard from the dollar store, put a hole in it, and then I just tape the lock onto the back of it. And then I have lots of room to put a little ruler up here and tape my piece of wire onto it. The only thing about this sort of situation is that you'll probably have to suspend this on a box or something so that the dial doesn't hit the bottom, hit the table when it's going around the bottom end of it. But this makes it easy, and this way it takes away one of the skills, which is reading the dial super accurately. It makes that easy, and that is a hard skill to do. So your first few times, your first, even forever, you can do this and you can concentrate your skills on how do I get my dial to be exactly on the contact point to take the reading, and also just about the manipulation and interpretation. So I recommend this, and it really does help for making accurate readings of the dial. Let's look at the two skills that we need to do in order to get this to work. And the first skill is getting the contact point, so right where the nose meets the edge of that cam. And there's two sides. There's this side and this side. This is going to be the right contact point. It's the one that's curved, and that's the most important one. The other one we I don't tend to use very often. Once I've done my scan of the dial, or sorry, of the wheel pack, and then I want to confirm my numbers, which we'll talk about in the high-low test, I will use that. But in general, I don't use it just because just the shape doesn't really make it ideal for getting good context. Just a small movement of the nose may or may not make a difference on this. But it can be useful, but I usually just use this one, and most people will say this one as well. So if we look at this down in the right corner, we see the ruler, the millimeter ruler, and if we look at that, that's going to be 5 centimeters or 50 millimeters. This would be 45 millimeters. This would be 40 millimeters. So this gives, as you can see, between, let's put that as close to 12 as we can get, the dial to 12 as we can get it. That's about 5. And if we go to 13, we are at just under 4. So we get an accuracy of about a tenth of a number in this. So let's look at some differences. Now, this is probably the biggest difference you'll see. If you look up in the wheel pack, you can see wheel 3 and wheel two's gate are right over top of the fence. I've already entered in those two numbers. Wheel 1 is not, its gate isn't there, so it's going to be blocking the wheel. And this will give us, usually if you have two gates in, especially including gate wheel 3, it gives a good indication. So we're going to take a reading. I'm going to just do the reading, then we'll come back and talk about it. And look at this here. Just do it a couple of times here. We're getting about 51 millimeters, just 1 millimeter off the 5. So 51 millimeters. And you can see, totally easy to read. That's really easy to read. That's why I love this. You don't have to think about it. Um, I find it so much easier. Other people really like reading the dial, and that does give you great information. You don't have to sticky tape your ruler on the safe and put a piece of wire on it. So it's nice for that. But I really recommend this because it's just going to make your life so much easy. You need to learn some skills, and this actually helps you learn those skills. Um, because even the slightest nudge, if I pull the dial just slightly higher, you can see I can get a reading. I can move it 3 or 4 millimeters there just by how hard I'm pulling on that dial. And we'll see that in a few cases. But the idea is to get it is do it exactly the same. And now you're going to be really accurate. I can tell. Every time I do this, I should get 49 millimeters. Or sorry, 51 millimeters. So we'll talk a little bit more about how to do that. You can see my finger just kind of rubbing the top of the dial. That's with 2 gates. So that is, and it's pretty much exactly at 12 on the dial here. So let's look at it if we zero all these or get rid of all those so that we now have nothing, no gates underneath the wheels. Here's a typical location for that. And let's redo this measurement. You can see here we are at about 46, just about 46 and a half. So that is, let's see, 46, that'd be 4.5 millimeters, which is about a quarter of of a number. And you can see if you look up here, that, oops, we're at 46 again, that it is about 12 and a half, maybe a little bit less than that. So we've done about a half a dial, half a number here. So these are small movements, and that's why using this this measurement down here really helps. So let's actually go through and look at how to sort of practice this and how you actually take these measurements. So what you will do is you'll have the wheel pack set to where you want to make your measurement. Then you'll, like for example, let's just move this to a new location here. So we're at a new location here. This is at what, 30, 35, 36, about 37. And you'll see there is a little bit of slop in that wheel that does make it a little difficult to properly manipulate this. But we'll see, we need consistent answers. So just randomly set this to about 32, and then we need to turn the dial back so that the nose drops into the contact, the cam gate, between the contact points. And then we're going to need to maneuver the nose so it's just touching it. And this is a skill that you're going to have to practice, and it works really easy when you're looking at the millimeter as opposed to the dial, because you can see tiny little changes. And we're going to see, this is going to be about 45 and a half, but you'll see that it is quite difficult. You can see as soon as I take my finger away from, I put pressure on it, and then it moves, and it moves a lot. So I tend to, when it's doing that, just move it till I feel a little bit of resistance. So that looks like it's at 44 between, and you can see the harder I press it, and these are very minute changes. That's about 44, and it relaxes. It goes back down to 46. And this is a little bit, if you push too hard, I'll exaggerate here, you can see the nose being lifted up. And you don't want that. So you just kind of come up and you're just going to try and find what works for you. You need to get a super consistent. Every single time you do this, you should get exactly the same number. And I suggest you just try and get it so that you may want to hold some pressure on it. Like my hand's away from it, and it's saying 40, 45.5. So I'm going to move it again. And I'm going to, again, it goes to about 44 and 44 to 45, then to 45.5. So again, I'm at 45.5. Let's see, again, 45.5. So I'm getting consistent results. So that would be 45.5. Let's do another one. Let's do one, say, let's do it here again. Set your wheels, come back, let the nose drop in, and then bring it back to the contact. So let's try and see what this one is right here. And it's just a skill. You just have to keep practicing this. Keep practicing this until you've got really high consistency. And you can see that this is about 46. I'm just sort of taking my finger on and off, just kind of giving it a really, just the right the normal the same amount of force on it. So yeah, that's about 46. So let's do another one. And let's actually set this one to, let's say 78, which is where the wheel one gate is. So we'll see if that makes a difference. So we'll drop the nose back in, move it back to the contact point. You can see when I release, here, I'll do this up here. When I bring it against it and then release, it just kind of slowly kind of falls itself back. So you need to come up with a really consistent way of doing that. So that's about 47 there. Let's see, 46, 47. And this is where it's just skill and practice to try and do this. Yeah, so I call that 47. So there was a minor difference here, even though this wheel is probably being shadowed by wheel 2 and 3. Let's try a different one. Let's try 24, which is the middle wheel, wheel number 2. So you see we got a gate over top of it, and we'll move back into the contact area, and again. So this one here is again at about 46, and so that one's probably not going to be indicating. So either wheel 3 or wheel 1 is shadowing it. And if we go over to 50, again here we're getting about 48, 40, 45, 46, 47, 48. And again, and that is indicating that there is a lower point, a lower part of the wheel pack underneath the fence. So this is the basic skills you need to know. And just practice and make sure you get it consistent, which is putting the nose right up against the edge of the cam and getting a nice consistent number. And you will have to kind of, I find that just kind of stroking the dial kind of helps to sort of set it so that it's not wanting to move in either direction. And you're just going to keep doing that. This is just practice right now. We'll just put the wheel pack in a location and then try and take a measurement. And I just find I just play around with it for a little bit. So I see this one here is 45, 46, 47, and then I'll try it again. Oh, this one is, you can see it went up to 46 or 45, and then relax. And then I kind of just make sure that you're not pushing on that nose. Make sure it's against it, but not pushing it. Because as soon as you push on it, like I can just push it slightly, and now I'm at 45, and now it comes down by a little bit. So sometimes the nose will push it back, but sometimes it's also that pushback is just the dial, some slop in the dial. So it's just about practicing, 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 and you should get consistent numbers. So if we go, let's try it at, let's say 70. There's nothing there. So we'll go to 70. So go to a number where there's nothing there, and you just make a reading and try and get it accurate so that you are really sure that it's within at least 1 millimeter. So that's 45, 46, 47, 48. So that was, what did I say that was? 70. So let's go to 80. Actually, let's not go to 80 because that's right next to a gate. Let's go to 90. 92, fine. Just keep doing this around the dial. Try and get a consistent number. And you'll find that usually on a group 2 lock, you're going to get really consistent numbers. So let's go back to our, let's just do 70 here again. We should get the same number because the 3 wheels are in the same position. If you don't get the same number, then you're not being consistent, and you need to be really consistent, because using this millimeter scale here, the reading for a gate's going to probably be about 2 millimeters difference. And as you go around the dial, you'll find there's probably about 2 millimeters difference just around, just by going to the different generic heights of the wheel pack. So it's really about being very gentle and very consistent, and just keep practicing, so you still get the same numbers. Go back, rotate the dial around again. Let's go to 70 again. And we will, again, try and get the same number. And we're going to rotate it around to 70 again. Make sure you get the same number. It's just about stroking the wheel and making sure that you can just, when you're doing it, you see the needle floating around between a few numbers as you're doing it, then you know that you need to be super consistent. And that's basically how you do a reading.